these functions a little bit. So I'm going to go kind of back and forth between like kind of doing the work on the whiteboard over there, and then eventually coming over here to the projector to get some graphing done. So you'll want to have graph paper, straight edge, calculator, all that stuff out, and probably a good idea to jump onto Canvas, which you already did because here you are, and open up the presentation that I linked to that spot. So you can, if you want to, you can pull up the problems that we're going to work on. Starting with number 2. We might have started it depending on what class you're in. We might not have. So if we got to jump on that, cool. If not, then we'll start fresh, which will be nice. And we're looking at this one. And I just want to do as many as I possibly can in the next 45 minutes. Okay, so I'm going to go a little bit faster than I probably did with you last time, only to work just through as many as I possibly can. But slow me down if you need to. Okay, so do this work with me. I also put the homework up for this weekend to give you some practice. I also put up the test. Kind of break down what's going to happen in class and what's going to happen at home, and what you want to study for each one, and how that all is going to play out. So when you're going to expect to get it and all that stuff. So ask me questions about that if you have that too. But let's do it. Let's just kind of run through it. Looking at number 2. Okay. And what we always want to kind of start with is, can I factor and simplify, right? Because that just makes things a whole lot easier to look at, and it'll also give me a clue about asymptotes versus wholes and things like that. And really, there's no factoring to do, right? There's nothing up top, just linear and no GCF, and it's just an X on the bottom. So we're good to go right there, okay? So from there, we can start kind of figuring out what X values are not going to work because they would create 0 in the denominator. Well, the denominator is just X, so awesome. X can't be 0. And that's the only one, right? It's only linear, so we're going to have one spot that we really have to worry about. Okay. And what we want to kind of decide from there is whether or not that's going to make a vertical asymptote or that's going to make a hole. Okay. And because we didn't divide anything away, we know that there isn't a hole. That would have to come from that common factor, both top and bottom. So guarantee we've got ourselves a vertical asymptote at that spot. And that just happens to be the y-axis, right? X equals 0. Okay, no big deal. That's where it'll be. We'll get closer and closer to that axis, but as we do, we'll kind of take off in either direction. Okay. And then lastly, with the 2.6 kind of mindset about the stuff that we want to keep track of is like where we're heading when we go all the way to the left edge or to the right edge, right? That end behavior. Are we going to head towards 0? Are we going to head towards a different y value? Or are we going to have some slanted asymptote that we'll have kind of to use as a guide? Now, and that's always just going to be a conversation of degrees that you want to have, okay? And the good news, I guess, for you guys, because this is the newer stuff, this is the stuff that you'll do at home next week for our test. 2.6, 2.7 will be the take-home stuff. The 2.4, 2.5, that's going to be the stuff that we'll do in class, okay? So I'm looking at degrees, right? Degree 1 on top, degree 1 on bottom. So when the degrees are the same, it's just going to be the ratio of the leading coefficients to give me my horizontal asymptote. So that'll be y equals, we got 2 on top and we got a 1 on bottom. Okay, cool. Y equals 2. And we're good to go. And that's kind of what we got to in 2.6, right? And what we started to look at in 2.7 is trying to find some points that do. And it's always a really good idea to start looking for some possible x-intercepts, and if it exists, a possible y-intercept. Okay. And what we talked about last time is that x-intercepts are going to happen when the numerator is 0 only, right? And so in your mind, really, whether you write it down or not, you might be able to kind of just visualize that in your mind's eye and then just do it. But that's really what I want to do. Is I want to take 2x minus 1, whatever the numerator was, set it equal to 0. I know it's a little small, but we got lots of points we want to find. So let me know if you can't see anything. But that's what I want to do, is I want to set that numerator equal to 0. And I know it's not going to create a problem in the denominator, because if there was a 0 from the top that is also a 0 from the bottom, we would have factored and divided that away at this point, which is why we always start with factoring and simplifying. So I'm not worried about trying to figure out a 0 from the top, that's actually going to give me a problem this kind of late in working through the problem. Okay, cool. So I'll just solve for x. There's only one x in the problem, so I can go get it. I'm going to add 1, divide by 2. So that'll be at 1/2. Okay, and the y value, of course, that goes with that is 0. Okay, so that'll be a point that I plot for sure. But when I think about the y-intercept, that's supposed to happen when x is 0, right? But x can't be 0, right? It's the ratio of those constants that we would see at the end, and this is really like x plus 0 on the bottom, right? So -1/0, no, I can't do that, that's undefined. And so in this case, which makes a lot of sense because we have a vertical asymptote at the y-axis, I don't have a y-intercept because I can't exist if I've got an asymptote going up and down at that spot, minus an x value that doesn't work. Great, there we go. And so what I can do from here is just start to give myself a nice collection of points. Okay, and whether you write this whole thing down like I've done so far, or you just kind of create a list of points that work for you, that's kind of up to you. But in calculus, we're going to kind of want to have this mindset of looking at the different x values that we've found so far, right? So I'm just looking for an x. That's not an x, that's a y. I don't care about that. X equals 0 and x equals 1/2. Those are the only 2 x values that I've got in this problem. And if I have 2 places that I need to stop and draw something, whether it's an asymptote, an intercept, a hole, whatever it might be, if I only have 2 spots, what I've got are 3 sections kind of created by those, right? So I'm going to have this section over here, and then I'm definitely going to stop at x equals the first one, right? And then I'm going to have this section, and then I'm going to stop, and I'm going to have x equals something over here, and then I'm going to, have this other section, right? There are my 2 x values. One of them is 0, the other one's 1/2. And so I've got to the left of 0, in between the 2, and then to the right of that last one. And if I think about the actual points that I want to kind of plot in these spaces, the more points I have, the easier this thing is going to be to just connect them and sketch them. So I am a big, big proponent of saying, get a whole bunch of points. Why not? Then you don't have to guess your way through it. And the calculator from here is going to do the rest of this work. I just want to know where to look. And so like maybe you do start graphing right now. And maybe that's not such a great idea, but maybe you do. And you say, all right, I'm going to give myself a space to work, and then I'll just kind of fill in the gaps from there. That's your choice. I'm going to think ahead before I start plotting anything so that I can create a space that's going to work. I don't want to make it too big or too small. And so I look at my x values, 0 and 1/2, and I just want to go left to right. And so 0 is going to happen before we get to 1/2. Right? So I'm going to put them in that order. This way I can kind of fill in the gaps in between. And I know what's happening at x equals 0. That's a vertical asymptote. I don't need a point there. In fact, I can't have a point there. And I know what's happening at 1/2. That was one of the only x-intercept that I've got. And so the rest of the space is just time to kind of fill in from there. Starting, it's getting a little wet. Starting at -infinity. It's a little better. Can you see that? Okay. And ending way over here at positive infinity, right? I just want to fill in everything in between. And these x values are where I stop and start each of my sections. So, okay, -infinity to 0. And I'll just kind of fill in a point there. Between 0 and 1/2. And then from 1/2 to infinity. And the bigger the space, the more points you're going to want to have. Okay, the smaller the space, you might only need just 1, maybe 2 at the most. But in this kind of large, really, really big space, I'm probably going to want a bunch, maybe 3 or 4 points, and get more if you want, absolutely, to kind of fill in between, right? Same thing over here, bigger than 1/2, all the way to infinity. Yeah, I want a whole bunch of points in that space. The more the merrier, right? Now, but between 0 and 1/2, that's a really small space. I probably just need one point in there, okay? And so from here, what I do is I jump into my calculator. Hi, I'm over here now. And I let the calculator find all those points for me, okay? So what I'm going to do is I'm going to jump in. I'll go to y equals and I'll type it in. Numerator was a binomial, so I got to make sure that I put that in parentheses. The denominator is just a monomial, so I can just divide there by x. And then I just go to the table and I think about what points I want. what points do I want to kind of jump in here and start looking for? And if I get nice numbers, then I'll use them. If I get some numbers that maybe I don't love, you can use them and just kind of estimate their location, or you can pick a number nearby and see what you get. But really, I want to be close to 0, right? I want to be close to 1/2 when I look in these big spaces, because I don't want to create a graph that goes from like -50 to 50. That's huge, right? Especially if I have points at like 1/2, right? So everything in green is an interval, okay, up here. But so I'm looking for points pretty close to 0. -1, -2, -3, -4 look really good. -5, -6, numbers like that are the kind of numbers that I'm looking for. Okay, and so we'll go back and we'll plug those in and we'll see what we get. But let's do it all at once. How about between 0 and 1/2, right? Again, this is an interval here. All right, so 0 and 1/2, a really small space. So what I'll just do is I'll find the middle in between. How about 1/4? All right, we'll plug that in. We'll see what we get. Okay, bigger than 1/2, right? Less than infinity, bigger than 1/2. So I'm looking for numbers pretty close to 1/2, like 1, 2, 3, and 4. Those seem like a really good set of numbers to kind of try out. So let's just drop them in. -1, -2, -3, -4. Those aren't bad. This 2.33333, that's not that bad. It's just, you know, between what's going to happen at -2 and what's going to happen at -4. Maybe you don't love that though. You know, maybe you try -3 and -5. You like those numbers any better? Not necessarily, right? -4, -5, -6. There's lots of different choices, but I like the ones I picked. I'm gonna just stick with them. I'm gonna estimate anyway when I graph them. Okay, cool. How about let's go back. 1. Get out of here, you. 1/4. Ooh, that's a nice one. -2. Cool. And then 1, 2, 3, and 4. Yeah, I just plug them in. And I'm just going to estimate those anyway. And what this kind of gives you can see this table because I'm presenting it now, is a good sense for, you know, some of the x values and the y values. You want to make sure that your graph can fit, right? That's kind of the point. I want to be able to look at, you know, these collection of points and see what I get. So, so let's write them down. So we have a space, right? Because as important as it is to let the calculator do a lot of this work, what I'm going to be looking for on this take-home portion, so 2 1/3, 2.33333. So if it was just 2, that'd be, we're talking about thirds, we got 6/3, so that looks like 7/3, okay? And then 2 1/4. That looks good. At 1/2, 1/4, sorry, we're at -2. And then 1, 1.5, 1.6666 forever, so that's 5/3. And then 4, 1.75. Okay. If you round there because you're not sure exactly what that fraction is, I'm not testing you on your ability to change decimals to fractions. Rounding's fine. That's okay. Let's stop presenting and let's get this thing graphed. I'm going to slide this over to the graph. Okay. Hi, let's do this. I'm going to give myself a space to work. Okay, so I'm going to go through and I'm just going to start looking at creating a space that's going to fit everything in here. Okay, and this is really the one that I'm going to talk through the most. And then we have, you know, a handful of minutes after this, and we'll just kind of fly through. I might end up not being able to get all of them done, but that's okay. We'll have the review and solutions that go with it, so hopefully that'll help you out a little bit. Okay, cool. Set of axes. All right, so here, time to go. All right, so set of axes. Let's draw that a little bit closer to that actual line. What do you say? Make it a little thicker too, so my mistakes get hidden a little bit better. Nice. And then, I don't know, somewhere down the middle. Okay, I can always make them smaller or bigger. We're using pencils, right? So we have that ability. Okay, arrows on the ends. Labels for your axes. Okay, so I've got x down here. What's the function f of x? Okay, so my y-axis, I'll just call that, again, ignore the stray marks at the top there. It's imperfect projector and the way it kind of reads my touch there. And then I just need a scale. But I want to make a scale that fits all my points. And this is where I kind of look back at my collection of points and make sure I can fit everything. Okay, my smallest x value is -4, so I want like at least to get to -5, -6. I want a little extra space. Biggest one is 4, it's the same thing that way. So I want to make sure that whatever I graph here, I can fit all of those x values. And so if I create a space that does that, 1, 2, 3, 4, and then a couple, nice, -1, -2, -3, -4, and then a couple, that should be enough to give me the space that I want. And usually going by ones is not a bad idea because we can estimate in between really well. You want to go smaller, that's cool too. This works for me. Okay, same thing up and down. I want to think about the numbers that I've got and make sure that they fit. And if you just kind of look back, right, at that table that we created, what hopefully we've got is a space that does what we want. And so I'm looking for like biggest y values and smallest y values. If I look at my collection of points there, it looks like my biggest y value is a 3 at the point -1, right? And my smallest y value is at -2. So I just want to make sure that I can get to 3 and then a couple, get to -2 and then a couple. So I think if I go like this, 1, 2, 3, and then a couple, nice, that should fit. If I call that 1, 1, -2, and then a couple, nice. Okay. Give yourself enough space to do what you need. Okay, and now we just start graphing, and I'm just going to go in order that we found everything in. So I'm going back to my work that I did, and I'm looking at everything that I've written down. I'm going to do asymptotes, I'll do holes if they exist, intercepts, and then I'll plot my collection points. Okay, so I know I have a vertical asymptote on the y-axis, and when I graph asymptotes that exist on axes, one, color is never a bad idea because that can really kind of stick out. So I'm gonna graph that. I'm going to do it just a little bit thicker though. I'm going to do the thicker version of this pen so it really stands out. You want to do it dashed, and you're going to want to use a straight edge. I have to kind of freehand it being on here. And really, you want to go past the kind of edge of your arrow there for your axes. And you can always label it too, right? You can say vertical asymptote at that spot, right? So I can come over here and say, okay, there's a vertical asymptote right over there. I know I want to be kind of close to that arrow though when I graph though, so I'm putting that VA kind of out of my way. If I had some space above, I'd actually probably draw it above, so it was off the graph a little bit. Okay, and that's my only asymptote that's going up and down, but I do have a horizontal one that's going left and right, and that's at y = 2. So I take up my straight edge and I draw a dashed line, and usually I cut through my axes when I draw my asymptotes. Cool. Arrows on the ends, and those are going to be my targets, right? That's what I want to try to aim for on my left edge and my right edge. That's what the end behavior is. All right, time to just plot some points. All right, I've got an x-intercept at 1/2. All right, so it's halfway between 0 and 1. So I put a little point right there at 1/2, and then I just fill out all of the rest of the points. I'm just going to drop in kind of what I wrote on that table onto this graph and see what I get. So -1, 1, 2, 3. So I got a point right there. -2, 2.5. 2 and a third. So that's even lower, but not quite all the way down there. And then -3, 2 1/4. Right? And you can see that we're starting to kind of trend down towards that asymptote. As we get closer to this arrow, we better get closer to that asymptote. Right? Okay, cool. All right, there's my my 1/2 spot. That one's done, but I do have a 1/4, so that's gonna be halfway in between, way down here at -2. And then we've got 1, 1, 2, 1.5, 3, 1.6666666, just a little bit above that, and then 4, 1.75. Okay, and if that's enough for you to kind of make your connections, then great. It's time to start connecting those points. But you want to have some arrows as targets to aim for. And since my whole graph in this section kind of exists like this, and if you kind of follow the trend of this graph heading from the right to the left, you can see that we're getting closer and closer to that asymptote. And so this arrow is going to exist in the space either above or below that asymptote. And because all of my points exist above right now, I feel pretty good about putting that arrow above. Okay, so that's going to be my target on the left. Same thing on the right, right? If you follow these points, it's pretty clear that up we go, heading towards this asymptote. So I'm going to put my arrow over here on the right edge below that asymptote. And that kind of takes care of my end behavior. Okay. All right, now as we approach the vertical asymptote, we just want to do the same thing. I just want to kind of get close to it from both sides. And here I'm staying on the right side, so I'll just go from here. As I follow these points, down we go for sure. So I'm going to put an arrow over there on the right. Same thing over here on the left. As I kind of move towards this asymptote on the left, we see a trend kind of heading upwards, but maybe you don't feel confident enough about that yet. Maybe you say, you know what, I found what happens at -1, but I kind of want like a -1/2. Or a -1/4, or a -0.1, or something getting just a little bit closer. And what you'd see is you'd just be getting, if we dropped in -1/2, you'd probably, let's see, -1/2, -2, you'd be up at -4. So 1, 2, 3, 4. You'd actually have a point right up there. Okay. 1, 2, oh no, sorry. Not there. We've got a point right here, -4. Okay. And that might be enough for you to say, all right, my arrow is over here on the left-hand side. So next to your arrows for your asymptotes, you will always have arrows for your functions on one side or the other. And sometimes with vertical asymptotes, we might be both heading up. So maybe you have arrows on both sides, but you're going to have arrows on the left side and the right side somewhere for your vertical asymptotes. And now we just connect them, right? I'm going to kind of hug this asymptote until I get to my point, and then up I go. All right, same thing here. I just want to kind of, from the bottom edge here, I really want to be really close to this asymptote, heading towards that point. Again, we want to draw a function, so we don't want to have them be perfectly vertical at any point necessarily. Again, ignore some of my stray marks that show up, just because I'm doing it on the projector, but there we go. And you have a calculator. You should be able to just press graph right here, right now. That'd be so weird to watch me bounce around from one screen to another. But if I go back in and I graph this thing, oh, I'm in a weird window because I was looking at something in Algebra 2. If I zoom standard and then zoom square, there it is, looking pretty good. Right? Looks pretty good. Of course, this window is a little bit bigger than ours is. You can always go in and adjust your window to be exactly as big as you made your graph. Looks like -7 to 7. And y min was like -5. -5 to 5. Maybe that window giving you the exact same space to look at makes you feel a little bit better about what you've got. Okay, so that's pretty cool. All right, and so that's the basics. And from here, with our last 10 minutes, what I want to really do is kind of work through some of these other ones that have some different kind of things going on. So if you look back into that spreadsheet, not the spreadsheet, sorry, the presentation, there's some other stuff that happens that I just want to take a look at. And so what I might do, because I'll probably go over time, is I'll let you leave whenever you have to go. But if you want to stick around, I will do more of these problems. I could probably only have time to do one more. So I'll do number 3. But if you want to stick around and see 4 or 5 happen, because number 4 will have a hole, and you want to see what happens there. So you can always come back and look at it. You know what, though? I want to do that. Let's just do that one. Let's just do 4. Let's do 4 instead of 3. Okay, 3 is nice because it has 2 vertical asymptotes. So I want to make sure you see what happens when you get 2 vertical asymptotes, because there's now 3 sections of this graph and different things are going to happen there. And you definitely want to see what happens with number 5, because the degree on top is larger than the degree on bottom. And so now we have a slant asymptote, and I want you to see that too. So I'm going to keep teaching. So if you have to go to get to a 3rd period class, you can go once we get to what, 9:55, is that what it is? So we have a little bit of time. So stick around though if you can. I'm going to jump first. Is it really 9:55 though? Do I have more time than I think? Oh, it is. Okay, so I do have 20 minutes. All right, so I'm going to do, sorry, my brain is all over the place today. I'm going to do 3, then 4. Okay, and if you want to see 5, then you'll probably have to stick around for that. Okay, let's do number 3. Okay, so new ideas. But same setup, right? Same number sense kind of taking us through this problem. But just a different early approach as we get this thing factored, because we want to see everything that we possibly can. Let's make sure I'm not presenting it anymore. Sweet. And let's bring this back over to here. And we are doing number 3. Let's do 3. I like that. I'm glad I have enough time to do it. Okay. Number 3. Hopefully the green is okay to see. If it's not, just give me a shout. X on top and x squared minus x minus 2 on the bottom. I'm going to go find the black or brown. So we got a little bit more contrast. Maybe this blue. Okay. All right. Number 1, factor and simplify if we can. And this is definitely going to be factorable. Hopefully factorable because we've got a quadratic. Brown doesn't go. So it's just x on top. But the denominator is definitely factorable. Right? We've got quadratic. So we've got our 2 factors. Sorry, we're going to be able to split this apart because it's just x squared. We've got x and x. And now I just want to know what 2 numbers add to -1 and multiply to -2. And that's -2 and +1. So x minus 2 and x plus 1 will be our factors in the denominator. But nothing to simplify, right? Nothing to divide away. I don't have any common factors, top and bottom. So I know already that there are no holes, okay? But I want to make sure I write down my domain so I can avoid the x values that are going to cause that problem for me. X cannot be either of those values that would make each factor 0. So with x minus 2, you get a +2. That's no good. And same thing with the other factor, a -1 would give us a problem. And if you don't like the fact that that order is not from left to right on the number line, then switch them. But it's just a set. This is a collection of numbers, so you can write them in whatever order you'd like. Okay. And again, because neither of those factors divided away, I know I do not have any holes, which means that those excluded values are going to be spots where we see vertical asymptotes, right? We're going to have one at x equals 2, and we're going to have one at x equals -1. Make sure you just write those separately. Okay, and then last thing in 2.6 is to try to figure out what's happening at the end. What am I shooting for? What are my targets on the left and the right edge as x gets really big or really big in the other direction? And it's a conversation of degrees, right? So degree on top is just 1. Degree on bottom is 2. So the degree on top is smaller than the degree on bottom. Always, always, always a horizontal asymptote at y equals 0. Okay, and label that horizontal asymptote versus a slant asymptote. Okay, cool. So there we go with our 2.6 stuff. Now we get into 2.7 and we start looking for x-intercepts. We start looking for a y-intercept if it exists, and then we'll get ourselves a collection of points from there. Okay, x-intercepts are your zeros from your numerator only. And again, I don't have to worry about creating 0 in the denominator with that because nothing divided away. And if it did, then I just plug it. I just look at the new version, the simplified version. It's just x, right? So what value of x could you plug in for x to make it 0? 0. And so the origin is going to be an x-intercept. Okay. Y-intercept happens when x is 0. Oh, well, I already know what that point is. It's going to be 0, right? Your y-intercepts and your x-intercepts can be the same if it's happening at the origin, right? That's where those 2 axes meet. So you actually have a duplicate set of points there. We'll just obviously plot it once. But there you go. And that's still the ratio of your constants, right? Remember, this is just x plus 0 over here, 0 over -2, 0. Okay, so that works. So there we go. Now it's time to get ourselves a collection of points. Okay, and what I want to figure out is how many unique x values I've got so far to figure out. I'm just going to circle one of them. I don't need both because they're the same. How many sections I've got that I want to fill in. Okay, and so I've got an x equals 2 vertical asymptote, an x equals -1 vertical asymptote, and an x-intercept, y-intercept at 0. So I've got 3 x values so far, which means I have 4 sections of points that I want to fill out. Okay, and again, if you want to graph it from here right now and then start filling them in, that's fine. You just may have to alter the size of the space you start to create. And so if you're going to like draw your set of axes right now, make sure you don't have stuff nearby. Now put it way off on the side. So if you need to extend your x-axis one way or the other, or your y-axis one way or the other, you can do that, okay? But what we've got, again, 3 x values, 2, -1, and 0, which makes 4 sections, okay? And so I'm gonna create, okay, so there's a section, and then I'm gonna stop at some x value. And then there's a section, and I'm gonna stop at some x value. And then there's a section, I probably need to tighten this up a little bit. Yeah, let's make it just a little bit smaller so I got more space. Sorry. And then an x value, and then another section. Okay. And so my points are going to go down here. Whatever collection of points I've got are going to go down here. These spots up here, for me, it's just a great way to get organized, are going to be my x values that I've circled from left to right. Okay. So I kind of have to pick and choose which one I want to put in which spot, so that I really do go from left to right visually, okay? And so I'm going to start at -infinity, right? And I'm going to, oops, don't close it yet. I want to end way over here at +infinity, and I just want to fill in all the spaces in between. So from left to right, -1, 0, and 2. Those are my x values that I have so far listed from left to right. And those are just kind of my breakpoints in this graph where different things are going to happen. Maybe it's an asymptote, maybe it's a hole, maybe it's an intercept. But I know that those are spots that I need to stop and fill in the gaps around it. Okay, and so these breakpoints are a great way to kind of create those intervals. Okay, from -infinity to this first one, to -1. Right, and then I've got an interval here between these two. Okay, between -1 and 0, and an interval here between these two. Okay, between 0 and 2, and then we'll just go bigger and we'll go 2 to infinity. And so -infinity, these numbers will match. 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 Infinity. Okay, so that's my setup. Okay, but I know what's happening at these x values. I've got a vertical asymptote here. I've got the point 0, 0. I'm just going to write the point. It's an intercept, and I've got a vertical asymptote here. So writing those characteristics down, I think, are going to help you stay organized as well. And now I just jump into my calculator and I fill in the rest. So I'm going to come back here. I'm going to present so you can see my calculator and see what I'm plugging in. And you want to do the same. This is the kind of thing that's not hard to do, but you want to just get comfortable pressing these buttons on your own, so that when you do this at home, it's not a surprise. And having it organized the way you see it up there is a really good idea. Okay, x on top is just a monomial, so I don't need parentheses, but trinomial on bottom, x squared minus x. Oops. Try again. X squared minus x minus 2. And then I go to my table and I delete all that old stuff. Delete a bunch of times, and I just want to get myself a nice collection of points. This is a really big space, so I want probably 3 or 4 or maybe more points in there. Super tiny space here, so 1's good. Pretty small space there, so 1's good. Pretty big space here, so let's get ourselves like 3 or 4 points in there. And I just go really close to this number. How about -2, -3, -4, -5? Might be good numbers, okay? Between -1 and 0, I'm just going to cut that in half. So -1/2. Same thing here between 0 and 2. Let's just cut that in half. Call that 1, like that. And then bigger than 2, how about 3, 4, 5, and 6? And if I kind of write those down, let me just stop presenting for just a second so you can see what I did over there. Right, between -infinity and -1, I get close to -1. Right, -2, -3, -4, -5. I get between -1 and 0, so I cut it in half. How about -1/2? Between 0 and 2, the number 1 is perfect. And then bigger than 2, I'm just going to go 3, 4, 5, and 6, and see what I get. And once I have that, then I just kind of jump into the calculator, and I take my my points that I like, and I find all of the y values that go with them, and then I'm going to create my space and kind of plot it from there. Okay, cool. Let's do it. Let's let the calculator do all the work for me. -2, -3, -4, -5. Not the best numbers in the whole world, but we can see the trend you know, -5, -0.3, -0.222, -0.179, all kind of getting closer and closer to 0, which makes sense because that's my horizontal asymptote. Again, not the greatest numbers in the world, but we're just estimating anyway. So I'm good with these. You know, the decimals aren't what we're hoping for necessarily, but it does give us a trend to follow. Okay. And I'm going to write these down. I'm not going to leave those in my calculator and leave them blank on my paper. I can't see your calculator when I look at your test, right? So I want to see this nice collection of points all written down. And because we've got some decimals, and maybe they're not easy to tell what those fraction versions are, then just write what the calculator is giving you. -0.5, -0.3. -0.222. I'm okay with that. Now that is -2/9, -2/9, but I definitely don't know what -0.179 is. I'm just going to leave it in the way that the calculator wrote it. That's perfect. I'm happy with that. Okay, that's enough accuracy for me to be able to graph it. Okay, at -1/2 we got 0.4. At 1 we're at -0.5, -1/2, and then 0.75. 0.4, well, it looks like 2.7 repeating, sorry, 0.27 repeating. I don't know what that is off the top of my head, so I'm just going to write 0.2778. That's fine. Right, whatever the calculator's giving you, 0.2143. Awesome. Okay, and there's my nice collection of points, and I'm just going to do the best I can to sketch this graph. Okay, it might not be perfect, and that's okay. I'm just going to do my best. Okay. I'm going to start creating the space here, but I'm going to leave the camera over there just for a second so that if you need to jot those down, you can. So you got another 10 or 15 seconds. But I'm going to start kind of creating my space over here. I know you can kind of see that if you're looking at my other screen, so I'll just kind of leave that up for now. But then I'll bring the camera over in about 30 seconds or so after I create my space. Man, so close. I don't even know if you guys can tell the difference at home, but it was off a little bit. Y-axis right there, x-axis kind of down the middle. Cool. Arrows. Labels. X and f of x again. Way up here, I've got f of x. And then a scale. All right, now if I want to scale, I got to look at the numbers first. And so you got to look and see, all right, what's my smallest x value, like furthest to the left, and what's my biggest one furthest to the right? Because if I can figure out what those two numbers are, then I can create an x scale that's going to work for the space that I've made. And so I know I have to go to -5, so then maybe even a little further, -6, -7, okay? And I know I want to get to at least 6, so maybe 7 or 8. And so I'm going to like kind of count my boxes and make sure that I can get there before I start marking it. 1, 2, 3, 4, 5, 6, 7, 8. So that looks good. 1, 2, 3, 4, 5, 6. It's a little tight, but I think I can do it because there's -7 right there by that arrow. If I didn't like it, right, if I didn't love the fact that it stops right there, erase it and then just kind of slide it over. Right, sorry, the book's in the way. Like over here on that left-hand side, right, like right there is -7, which is a little tight. Maybe you would take a second and you would erase your arrow, you'd slide it over just a little bit to give yourself just a little bit more space. That's up to you, right? The space you create is up to you. But for me, it looks like every box being worth 1 should do the trick. Every big box on here. So I've got dotted lines too. Those are good for my 1/2 and my 3/2 and stuff like that. Cool. And now up and down. My up and down numbers are super tiny. Look at those, right? I know I have a horizontal asymptote at 0. And all of these values are all small numbers, smaller than 1. And so if I created a scale that like put like a 1 right there, then the whole graph is going to exist in this space. And that is just a waste. I want to be able to like blow this up, really make it big so that I can like, 1, tell the difference between a 0.3 and a 0.2222, right? As best I can. So for me, I am not going to make one box up and down worth 1. Why? That would just be such a waste, right? What I'm going to do instead is I'm going to create a space that works for me. So I'm going to make 1, 2, 3. I'm going to make every 4 boxes worth 1. 1, 2, 3. Every 4 boxes worth 1 up and down. Because I can easily split that in my mind, right? If every 4 boxes are worth 1, then every box is worth a quarter, right? 0.25. Every 2 boxes is 0.5. Every 3 boxes is 0.75. And maybe because we're doing a kind of a different scale here, it might be helpful to write those down as good guides for you. 0.25, 0.5, 0.75, right? And even vertically underneath the x-axis too. Maybe you write some of those down as well. Maybe you don't have to. That's okay. It's kind of up to you. But here we go. Let's do it. Let's get this thing graphed. Okay. I'm changing color to plot some asymptotes. Okay. I've got a vertical asymptote at 2. So that's this one over here. I always try to cross my axis that I'm running into with my asymptote, so I know I'm doing it right. Okay. Arrows on the end. And you have a vertical asymptote at -1. Okay, so I've got a second vertical asymptote over here. Again, straight edge for sure, if you're at home and when you do this next week. Okay, if you want to write horizontal vertical asymptote, you can. It's pretty clear because it's dashed, but it's not part of that. I also have a horizontal asymptote at y = 0, so that's the x-axis. So I'm going to go a little past my arrow here on the left. I'm going to do it a little bit thicker. Again, crossing my asymptotes, crossing my axes as I do it, and way over here past that. That's enough. I like the color. I like the thickness. It makes it really stand out. Okay, and then I just plot the point. Let's do it. All right. Y-intercept 0, 0, which is the same thing as the x-intercept. And yes, I am about to cross the horizontal asymptote. That's okay. Remember, asymptote is used very loosely here. It's a guide for the edges. Okay, that's all it is. I don't care about what happens. In the middle, I can cross it as many times as I want. Here, usually near the origin. Those arrows are just really a guide for me. Okay, I definitely cannot cross the vertical asymptotes though, because those are x's that don't work. Okay, and then I start plotting some points. -2, -0.5. That's for me way down here. Okay, and if you don't remember that, it might be helpful, right, to jot down your scale so you don't misplace any of those points. Okay, that's up to you. -3, -0.3. Okay, so I don't know exactly where that is, but I'm going to do my best. 0.25, 0.5. It's a little bit closer to 0.25 than it is to 0.5, so I'm not quite halfway. 0.22222 over there at -4, so that's got to be a little closer to the x-axis than -0.25, because it's 0.22. And then 0.179. Not quite halfway in between, a little bit closer to 0.25 than it is right there. And again, I see that trend kind of heading towards this arrow, then great, I'm going to put my arrow there on the left. And I see it kind of heading down towards this asymptote, great, I'll put my arrow down there. Why not? Okay, but what's happening in between these asymptotes, I'm definitely going to need some info for sure. So I've got the -1/2 and I got 0.4, so that's right there. Okay. And then between 0 and 2, I've got 1, -0.5. Okay, and maybe that's not enough for you. Maybe you think you need some more points, and maybe you say, okay, I need like a point in between here and a point in between there. The more you've got, the better. But as you kind of follow the points from right to left towards this asymptote, you see they're going up, so I can be pretty confident that I'm going up. And the graph, you press graph in your calculator, it'll confirm that too, okay? And coming down this way, I'm heading down, so okay, down we go, like that. So I can start drawing my arrows on one side of the asymptote and the other, okay? And then to the right, I've got some points over here. So I've got 3.75, so it's up here. 4.4, so just a little less than 0.5. At 5.2777777, so just a little bit above that 0.25. And then at 6, just a little below. Okay, you can see as we head from right to left, up we go. So I'm going to put my arrow up here. From left to right, down we go towards this arrow. I'm going to put my arrow there. And if you don't like this, if this is not enough points, just plot some more, okay? Connect them arrow to arrow, arrow to arrow, smooth, rounded. There's no sharpness to it. There's no straight lines at all anywhere, okay? And then arrow to arrow. Crazy, right? Aren't these awesome? I love these. These are so cool. And we're just doing like basic, simple ones. I know, simple, right? Really simple versions of these. So that's 9:55. So if you got to go, you got to go. I'm still recording, so I'm going to keep going. I'm just going to keep rolling and do a couple more with you. So if you want to stick around and see them, great. If you want to come back and watch the recordings later, that's cool too. Have a good weekend. Homework 2.7 is due Sunday before midnight. You'll get your review from me Monday, Tuesday, depending on when. I'll probably even just send it out Monday. That's what I'll do. I'll send it out even Sunday night if I get it done then. So you can get started on that. And then we'll go from there. Check Canvas. The chapter 2 test 2.4 through 2.7 is listed there, so you know what to look for. And you can start studying. I know. Study from that. All right. So if you're gone, see ya. Thank you. If you want to stick around, I'm going to do 4 and 5. So you can see those worked out. Okay, so you can see what those holes look like. Okay, that's a big one. We haven't drawn holes yet, so you definitely want to come back and watch this. Okay, but I am going to work a little bit faster now that we're doing more and more and more and more of these. I know I keep saying that, but then I talk it through. I want you to get it. I really do. So I hope most of the review that we do in class is you working through rational functions with me on Monday and Tuesday, because that's what you're going to have to do on your own at home. And I want you to feel confident in doing that. So back to the presentation and looking at 4 and 5. The other nice thing about this is these are all just examples from the book, not exercises that you don't have the answers to. These are examples that are already worked out. Okay, let me just plug in my laptop because I'm starting to lose battery. So looking at number 4. There it is. Hopefully it can reach. And this is why math is supposed to be taught in a class that takes more than 45 minutes. I cannot do this in such a short amount of time. It does not work that way. Okay, cool. All right, there we go. Plugged in, ready to go. All right, number 4. I'm going to pull it up on my own laptop so I can see it. Okay, good. Here we go. Number 4. F of x again? What do we call it? Yeah. Okay. X squared on top minus 9. And x squared minus 2x minus 3 on the bottom. All right, time to factor and simplify and see what we get. Okay, difference of squares on top, x plus 3, x minus 3, quadratic on the bottom. Trinomial, x minus 3, x plus 1, right? Two numbers that add to -2 and multiply to positive, -3, sorry. Add to -2, multiply to -3, -3 positive 1, and we've got some common factors, which means I can divide those away, get x plus 3 over x plus 1. Okay, and then away we go. Domain. Okay, all of the x values that don't work from the beginning, that's positive 3. That should be a set. Positive 3 and -1 from left to right in the order that I wrote the factors, not necessarily the order that they show up, which is fine, just a set. Okay, and now the decision, is it a vertical asymptote or is it a hole? Okay, vertical asymptotes happen if they're still left after I simplify. So the -1, x equals -1, is going to be a vertical asymptote. But we divided away the x value of 3. Okay, and so since right, with that x minus 3 factor. So because that was simplified, that's where our hole is going to be. And to find the y value that goes with it, I just want to plug in that x value both top and bottom and see what we get. Okay, 6 on top, 4 on bottom. So 3/2 or 1.5, either one's fine. I'll go with the 1.5. It's not a bad number. I like it. Either one's cool with me because that fraction is simplified and the decimal has an end. Nice. So we're going to actually plot that hole. We're going to graph a circle. We're going to put a hole in this graph somewhere. Okay, and then last thing in behavior. What is happening when x gets really, really big? Degree on top is the same as degree on bottom, so horizontal asymptote at the ratio of the leading coefficients, x squared over x squared, so just y equals 1 over 1, which is 1. Sweet. Okay, good. Now some intercepts. All right, x-intercepts first. X-intercepts first are zeros from the numerator only, and so I look at the end. Because I don't want to include 3 because it can't be an x-intercept if there's a hole there, right? That's why 2.6 happens when I teach it first. We got to find the stuff that doesn't exist. I don't want to mistake that for an x-intercept. Really, I want to look here at the end and see what I've got up top still left over that's going to make it equal to 0, okay? And so the 0, if it's x plus 3, what x value could I plug in there? I can plug in -3. To give me 0. Okay, y-intercept happens when x is 0, and we just want to figure out the y value that goes with it. And if remember from last time, if we plug in x everywhere to be 0, the only thing that's left are your constants. And whether you pick the original or the simplified version, it won't matter. Okay, the x-intercept will be, or the y-intercept will be the same. -9 over -3 is 3, just like 3 over 1 is 3. Okay, so either one's fine. But it's that ratio of your constants at any point throughout this. Okay, you just plug it in 0. Great. All right. Now let's get ourselves a collection of points. I'm not going to write down a collection of points. We're just going to do them. Let's just find ourselves a list. But what I want to figure out is how this thing is broken apart. Okay, and so I'm going to circle personally all of the x values that I've written down. And there's 4 of them here: -1, 3, -3, and 0. And so if you've got 4 x values that matter, that means you have 5 sections of this graph that you want to find a collection of points for, okay? And so when I create my space here, I've got 4 and 5. I've got 9 things I better write down. So I better kind of write them small, okay? 1, 2, 3, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. What's going to go on top are my stopping points and my intervals. What's going to go on bottom will be my collection of points that I like. Okay. From -infinity to infinity and everything in between. Okay. So interval, stop at an x value. Interval, stop at an x value. Interval, stop at an x value. Interval, interval, stop at an x value. Ooh, good. I ended an interval. I have the right amount of space. Okay. Takes a little while to get organized, but you will thank me big time in like 3 months when we're doing the calculus that goes with this. Okay. Oh man, I can't wait. It's gonna be so good. Okay, cool. From left to right, all of my x values. I've got -3, 0, 3, and -1 are my 4 x values that I wrote down in this top half. That's why I wrote them down, so I can use them as a guide, but I want to go left to right. So I'm looking for the most negative number I've got for x, and that is -3. That's that one. Okay, so that one's done. Now just go left to right from there. That's going to be -1. Left to right from there, 0. The only one left is 3. And I know exactly what's happening at those spots. I've got the point -3, 0. I've got a vertical asymptote at x equals -1. I've got the point 0, 3 at x equals 0. And I've got a hole at 3, 1.5. And I'm going to write that down. I'm going to write down that I have a hole in this spot. Okay. And now I let the intervals fill themselves out, okay, using these numbers. These are my breakpoints, which means those where the intervals stop and start. -infinity is there to -3, right? From this point to this point, from -3 to -1. From this point to this point, -1 to 0. From this point to this point, between 0 and 3. And this point to infinity, okay, so from 3 to infinity. Okay. And now I just get myself a nice collection of points that go with it. The bigger the space, the more points I'm going to want to plot. The smaller the space, the fewer. Okay, this is a really big space, so let's get ourselves like 3 or 4 points. 4 is usually a nice enough set of numbers to get you towards -infinity. This space is pretty tiny, so I'll just do 1. This space is tiny, let's just do 1. This space also not super tiny, from 0 to 3. I don't know. It might be nice to have 2 points in there. The more you got, the better. So I never am going to hold myself back from getting more points. I don't want to do less. I always want to do more. This space is nice and big, so I'm going to get myself 4 points. So these take a while. They really do, which is why you're taking this home, and you're going to be able to work on this stuff at home rather than feeling rushed while you're in class. Okay, I'm going to share my calculator because that's what it's time for now. It is time to let the calculator do the work. Sweet. All right, so I am going to get rid of the function that I've got and type in the function that I want, x squared minus 9 in parentheses. Oops. Because it's more than a monomial. Same thing on the bottom. I need parentheses just around, get out of here. Just around the denominator. So you got the division sign in between, right? Not stuck inside a set of parentheses anywhere. Minus 2x, oops, minus 2x minus 3. Okay, and I always type in the original function. Okay, and let's go to the table. I'm going to get rid of everything here, even some of the ones that I might end up repeating. But let's figure out what we like, right? -3 is kind of that point that I want to get close to. So I don't know, where'd my green go? -4, -5, -6, -7. I like those, right? The ones that are close by. Okay. And we'll find out the y values, go with them. Between -3 and -1, I like to just go halfway. It's a nice even spot at -2. More is fine. You want -2.5 and -1.5? Cool. That's great. Okay. Between -1 and 0, -1/2, right? Just cut it in half. Always a good idea. Between 0 and 3, I have both 1 and 2. I like that. That's a really good spot to find 2 points instead of going to halfway in between and doing just 1.5. That's good. Okay, I like that. And then bigger than 3, how about 4, 5, 6, and 7? Okay. And so I'm just going to plug those in. -4, -5, -6, -7, -2, -1/2, 1, 2. And now here's the issue. My table only gets so big. So once I get down to that last number and I want to type in that next 7, it's gonna replace the 6. So I gotta write down what I've got first before I go in and find out that last one. Okay, so I've got 0.33333333. The decimals are fine. 0.333. 0.5 negative, positive. 0.5, 0.6. Just copying over what's in the calculator. 0.6, 6, 7. You want to call that 2/3? That's fine. -1. Ooh, big one. 5. 2. 1.667. 1.6667. 1.4. 1.3 repeating. 1.3333. 4 decimals is always a safe bet. 3 is okay if you really had to. 1.2857. Is that what that said? Yep. And then I still need something for number 7. So I'm going to leave the 6 here, I guess. So if you're looking, I'm going to put the 7 at the top. 1.25. Okay. All right. Lots of points, lots of things to look at. So it's time to start creating a space that's going to get me where I want to go. Cool. So new graph. New graph. Hopefully this is helpful. I'm glad that you're here, if you're still here, or that you're watching at home. To take the time for me to do this, I hope is worth your time watching. Cool. Y-axis, x-axis. I got a lot of points here, so I'm going to go way to the edge over here. I'm even going to extend this one way over to the edge so I can create a space that works. Okay. Arrows. Don't forget them. Don't lose silly points by forgetting to make a good set of axes. Not putting, arrows in the ends or a scale or labeling your axes, because all those points are really going to add up if you keep forgetting them, because we're going to do a bunch of graphs. Your take home is going to have a handful of rational graphs, so it's going to take you a little while for sure. All right, let's look at our x numbers and see what fits. Smallest one is -7, biggest one is 7. So I need enough space to fit it all. So I'm going to count first. I'm going to stop sharing because we've done enough. I want you to see me work this thing out. Don't run away. Come back. Okay. All right. I want to get to at least 7. 1, 2, 3, 4, 5, 6, 7, and a couple. Nice. -7. 1, 2, 3, 4, 5, 6, 7, and a couple. Perfect. All right. So every box is worth 1. Like that. And then up and down. I got to look for smallest y values and biggest y values. All right. So my smallest one just looks like -1. My biggest one looks like 5. So I got to make sure I can fit enough. So -1, obviously, I have the space to do that. But what about 5? 1, 2, 3, 4, 5. I don't really have quite enough. Okay. And so here's what happens. Maybe your graph doesn't have to be centered in the center. Okay. You don't have to put the origin in the middle of your graph. Okay. This is infinite, right? This is infinitely thin, but it goes on forever in every direction. And so what I'm going to do, and I'm glad that it happened this way, I'm going to move my x-axis down, because my biggest y value is 5, but my smallest y value is only -1, right? And so why create a space that doesn't value that? I'm going to slide, it used to be, what, here? I'm going to slide it down to like here. Okay. Now, for you, maybe you just say, you know what, I'm just going to extend my graph up a little bit. Maybe you just erase your arrow at the top and up you go. I'm kind of stuck with the space I've got here on the projector. So use your space well. That's kind of the point, right? So every box left and right is still worth 1 for sure. I'll kind of mark off those tick marks just to make it easier for me to count when I get there. And putting down 2 and 3 and 5 and all those -1s. That's cool. But then up and down, now let's see if I've got the space. 1, 2, 3, 4, 5, and a couple. Perfect. Every box for me up and down worth 1. So I got to get up to 5. I don't have a choice. -1 there, -2 there, right? -1 and a couple. All right. Now we can start drawing in everything in the order that we kind of found it in. That makes sense? I hope so. Okay. Vertical asymptote at -1. All right, there it is. So in my nice red, I would use a straight edge if I could. I'm going to cross the axis. I like to do that. I'm going to throw my arrows on the bottom and the top. And now I have an actual hole in this graph. Now it is infinitely small, technically, but I need to draw it large enough so that whoever's looking at this knows it's obviously there. Okay. And so when I draw this thing out, I'm still going to stick with the red. I'm just going to use a thinner marker so that it stands out. I can draw it a little bit bigger, but still create a space. I need to go to 3 and then 1.5. And in that spot right here, okay, I need to draw a hole. And usually what I do is I draw it big enough so it's obvious. And I try to put the center of that hole at the actual location of that spot, because technically it is so small we couldn't even see it with the naked eye. But I want to draw it big enough so that I've done a good job at kind of representing that. Okay, so 3, 1.5, draw yourself a hole. Okay, and those are the things that don't exist. Horizontal asymptote as well. Let's draw that in there at y = 1. Okay, so straight edge, y = 1. I like to cross my axes. Okay, arrows on the ends. Sweet. Okay, and now I can start plotting some points. All right, this part's going to go fast, and I'm going to connect them because I'm running out of time before I even get to period 4. So I'm going to start plotting some points. -3, 0, 1, 2, 3. Y-intercept 0, 3, 1, 2, 3. And then a bunch of points after that. -4, 0.3233, so third of the way. 0.5, -5, 0.6, so going up just a little bit. 0.6667, so going up just a little bit. Clearly trending towards that arrow right there. So the arrow's going to go there. At -3, we had our intercept. Good. -2, -1 down there. Clearly trending down towards that arrow on the bottom. I'm going to draw myself a target. Cool. -1/2. We're up here at 5. 1, 2, 3, 4, 5. 0, 3 is already there. Good. 1, 2. 2, 1.6 or 6. So this is a little bit above 1.5. A hole at 3, 1.5. So that one's already there. And then 4 is 1.4, just below that. 5, 1.33. Just a little less than that, a little less than that, right? And so do the best you can to try to plot all those points. Okay, and there's, look at all of these points, right? We had so many sections, now we have so many points, I don't really need to add anything else. I clearly see the trend heading towards that arrow right there, heading up towards this arrow as we move in that direction, and making that connection over here pretty easy. But when you make the connection over here, the reason that that hole is there is for you to go towards it. It's a target, okay? But I can't cross through it. I don't want to draw anything blue inside that hole. So I'm going to get right to the edge of however big I graphed it, and I stop. But I'm going to like kind of visualize what it would feel like to cut right through that hole and pick up as best I can where I would have left off on the other side. Okay, if you don't like the fact that that hole is red instead of blue because the graph is blue, fine. Draw it blue instead if you want. Okay, but that hole should be super obvious, really, really big. Like, you know, like half a box-ish size, something like that would be good. Cool. Okay, let's do one more. Thank you for still being here, or at least watching at home if you're still watching, because this will help you a lot. And if you get to next week and you're like, I don't know how to do rational function graphs, I'm going to say, go watch this video. Hopefully you're watching. It's definitely worth your time. Okay, cool. Because this test is coming up, and it's going to be, you know, exactly the kinds of questions we've been doing so far. But these are not necessarily easy since this stuff is newer to you than everything else that we've done basically so far this year. Hopefully you're feeling okay. All right, let's do one more. Let's do 2.7, example number 5. I just wanted to show you what happens when we start looking at slant asymptotes. I'll leave that. Why not? I got all that. I don't know what kind of space I need though. I don't know how many pieces I've got. Oh, the green really does not erase well. That's okay. All right. Number 5, degree 2 over degree 1. Let's finish this up. And then chapter 2 is done. Review going out as soon as I write it. Number 5, what do we got? F of x again. Man, I like f of x. I like to change it up. X squared minus x minus 2. Is that the same as the denominator from the last one? Oh, minus 3 was the last one. Same as the denominator from number 3. Okay. And then x minus 1 here on the bottom. Okay. Let's factor and see if anything cancels. Okay. Be careful when you factor. You don't want to hope that you have common factors if you don't really, right? It kind of seems like, ooh, x minus 1 looks really close. Well, it's actually x minus 2 up top and x plus 1. And neither of those are the same. Okay, you have no combination. So there's nothing to simplify there, right? Two numbers that add to -1 multiplied to -2 is x minus 2 and x plus 1. So we do not have any holes because nothing went away. And like if you want to write that right away, good. Have that realization, okay? And because we only have a linear denominator, there's only going to be one number that we can't use for x, which is 1. And if it's not a hole, it's got to be an asymptote. Okay. Now end behavior. Because the degree on top is larger than the degree on bottom, we have a slant asymptote at y equals something. Okay. And it's up to us to figure out what that something is. Okay. And that just takes division. Okay. Now, whether it's polynomial long division, if you have to, or set division if you can, that's kind of your choice if you are given that choice. I'll show you both so you can see it. Okay. Let's do the long division way first, because if we get stuck with that, we want to make sure we still have that. Divisor on the outside, dividend on the inside. Okay. And away we go. Now, we've done enough of this. Hopefully, this is not surprising you. First term on the inside divided by first term on the outside. X squared divided by x is x. So that goes up top. And then multiply that x through whatever you've got. Okay? And subtract. And see what you get. Okay? X squared minus x squared is gone. Those are 0. And then negative x plus x also gone. That's 0x. Now, I want that first term as something for me to use, right? Because I'm going to need, like, remember, I did x squared over x to give me that first term. I'm going to need the first term on the inside divided by the first term on the outside to give me something to multiply through, okay? To confirm, really, that the remainder is something besides 0. I really want to kind of have that feeling, okay? And so, really, there's like a plus 0 up here, right? 0x plus 0. Okay, good. Subtract straight down. That's a bunch of zeros, so nothing changes. It's still just -2. But at least I've got like kind of a complete version of what this looks like, right? And whether you do it that way or you do synthetic division with the 0, not -1, right? But the number that would make this 0 is a +1. And then the coefficients of your dividend on the inside, bring down the 1, multiply. There's the 0, multiply, right? There it is. Y equals, it was quadratic, so this is linear. 1x plus 0, that's y equals x. Okay, and we're going to graph that dashed line as an asymptote for us to kind of guide our end behavior towards. Okay, so we'll use that for sure. Okay, so I don't really have a preference if given the choice to do it that way or to do it this way, but show me one or the other. Don't just write this down. I need the work that goes with it. Okay, and I promise you there will be at least one on the test that has a slant asymptote. So I got to see if you can do it. And definitely 1 or 2 at least on the review so you can practice. Okay, now I see what x's I've got, so I can create a collection of points. All right, I've got an x equals 1. That's the y equals, not an x equals. Oh, I forgot to do other things. Oh, I need some stuff. I need some intercepts. All right, let's create a little tiny space over here. And let's see what we got. Okay, so x-intercepts first. It's like, where are the rest? There we go. All right, x-intercepts. Values from the numerator that would make it 0. I've got 2 factors, which means I have 2 x-intercepts, right? 2 values are going to make the y value 0. One is a 2, the other one is -1. Love it. Okay, and then my y-intercept happens when x is 0 and the y value goes with it, will always be the ratio of your constants. -2 divided by -1 is +2. Okay, there we go. Now we got some more. All right, so I got this one and this one and that one. I've got 1, 2, 3, 4 different x values where this graph is going to do something. Right? Something important that I want to stop and make sure I do well. An asymptote, an intercept, 2 of them actually for x, and a y-intercept as well. So 4 x values, so I've got 5 sections. That means 9 spaces of things I need to write down. So I should just make them the exact same size as the last ones I did. So I'm going to see if I can fit all, let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, what goes up top are my intervals and the x's that I just kind of marked down as being important, those critical values. Okay, we're going to start at -infinity. We're going to end over here at infinity, and we're going to fill in everything in between. Okay, interval x value, interval x value, interval x. Oh, I did it again. Interval x value. Interval x value. Ooh, good. I ended an interval. I feel pretty good about the size of my my table that I'm creating down here. But I just want to write them down from left to right. So I kind of have to step back for a second and look at my choices for my x value. Most negative first, right? And there's only one negative at -1, so that'll be my first one. That one's done. And then I just keep moving, right? My next x value is 0, then a 1, then a 2. Okay, and my intervals get filled in from there. Again, this is optional, but really highly recommended if you want to show me this collection of points organized in a space that makes sense, okay? But that's up to you. You have some freedom there, so do you think it works? Remember, these x values are going to be the only values I need to write down in these intervals. To -1, from -1 to 0, from 0 to 1, from 1 to 2, and from 2 to infinity. Okay, and I know what's happening at all these x values. I've got an x-intercept at -1, 0. At x equals 0, I've got a y-intercept at 0, 2. At 1, I've got a vertical asymptote. And at 2, I've got another x-intercept. That's at 2, 0. Okay, and I just need a bunch of points kind of in between. All right, so this is a pretty big space. So 3 or 4 sounds good. I'm just going to go with 4 there. This is a small space. 1 is good. This is a small space. 1 is good. This is a small space. 1 is good. This is a big space. So let's do 4 over there as well. Okay. So hopefully me saying the same kind of thing kind of over and over and over now, starting to make its way into your long-term, not just your short-term memory. But chances are, right now, it's just short-term. Okay, and the only way that changes is if you do it without me. Okay, practice, practice, practice. Okay, and that's what your homework is going to do. That is what your review is going to do. So you're going to see this stuff over the next week to get you ready. All right, cool. Close to -1. How about -2, -3, -4, -5? Halfway in between. Halfway in between. Halfway in between. And then 3, 4, 5, and 6. So I've got -2, -3, -4, -5. And then I've got like -1/2, 1/2, 1.5, 1.5, and then 3, 4, 5, 6. Time to let the calculator do the work. Look at you guys still hanging out here. You guys are awesome. Emma, Jaden, Aiden, and Zyla. My 4 favorite people in the whole wide world right now. So cool. All right, y equals. Write it down. Let's see this crazy function that we've got. And remember, you can just, I don't want to tell you to do it, but you can graph these things ahead of time and know what it's supposed to look like when you're done. If this was any other year, we would be doing these in class for sure, where you'd only have access to what you've got in front of you. So being able to do this at home with notes should hopefully make this a little bit easier for you. Okay, cool. I'm going to get rid of all these points. I got a lot of points to plug in here, maybe more than I can fit in my table. So again, I'll probably have to kind of stop and jot them down. -2, -3, -4, -5. And you see, we're not trending towards a number specifically like we have in the past, because we're going to follow an asymptote that has a slant to it. -1/2. 1/2, 1.5, or 3/2, either one's fine. 3, 4, 5. Oh, I can fit them all. Yay, nice. 3, 4, 5, and 6. Cool. And I'll just write those numbers down. Okay. Don't forget to fill out the table, and I'll tell you in the test for sure to remind you 1.333 that I need a collection of points. So I know where this stuff is kind of coming from. Okay, so -1.333, -2.5, -3.6, and then -4 looks like 6 repeating, so 6, 6, 7. At -1/2, positive 0.8333. Cool. At 1/2 looks like 4.5. At 1.5, we've got -2.5. And then 2, so 3, 2, 4, 3.3 repeating, 3.333, 4.5 and 5.6. Okay, cool. 4.5 and 5.6. All right, let's finish up this last one, and then you are free to go. And then you don't have to come back and watch it unless you'd like to, right? If you want to see me work through these again, the recordings will always be up there for you. Let's create a space that works for me. Okay, I'm pretty even left and right in terms of my x values, so I don't mind putting the y value, the y-axis, sorry, basically right down the middle. But you saw what happened last time, right? We kind of had to like backtrack a little bit when we were finding a spot for the x-axis, So I'm going to have that thought running through my mind now. Look at your y values and see if there's balance both above and below 0, right? And so when I go back to my list here, I look for the smallest y value and the biggest y value, and I see, is there a trend one way or the other? And so negative, like 4.666 is my smallest one, and my biggest one is 5.6. So they're pretty close, but the positive y value is 1 bigger than the negative y value. So if I'm going to put this thing down the middle, I'm going to need just like a little bit more space above than I would below. And so I'm going to have that thought right now and say, you know what? Instead of putting it exactly in the middle, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I only have 11 boxes. So this actually kind of works out nice. I'm going to make sure that I go just a little bit below the center. So I think for me that's going to be right about there. Okay. Now you can always avoid these issues by making sure your graph is bigger than it needs to be, not smaller. Okay. I'm stuck with the space I've got though. You are not. You've got a full piece of graph paper, and I'm going to give you lots and lots of blank space. Come test time to get this thing done. Okay. X-axis is X. Y-axis is F of X. And then scale. Let's make sure I can fit it all. I got to get to 6. So at least get to 7. 1, 2, 3, 4, 5, 6, and a couple. Beautiful. Every box to the right looks good. A little bit left. Got to get to -5. Yeah, plenty of space for sure. So every box for me, every big box. I don't know if you can tell from there, but I've got like solid grid lines and dashed grid lines on this graph. So I use the solid ones any chance I get. Cool. Up and down, I got to make sure. So 5.6. I have to get to at least 5.6, but I hope even more. So if I went by just 1, 2, 3, 4, 5, I can't get there. I can't do it. 5.6 is like at the arrow, and that's cutting it too close. I want a little extra space. So I'm actually going to make these half boxes. For me, I'm stuck making each one of those worth 1. Hopefully you don't have to do that. Hopefully you've created a space big enough where that doesn't become an issue. Okay, because then I work my way down, -1, -2, -3, -4, -5. It's not ideal. It really isn't. I wish I had a little bit more space, but I don't. Okay, you do, so use that. Cool. All right, asymptotes first. Holes, all that kind of stuff. Okay, vertical asymptote at y equals 1. Sorry, x equals 1. Vertical asymptote, x equals 1. I like to cross the x-axis with my asymptote when I do that. Arrows on the ends. No holes, like we did in the last one. I'll definitely give you at least 1 or 2 on the review that have a hole in it. But now I've got a slant asymptote at y equals x. X equals 0, right? And so remember how to graph lines. Start the y-intercept and then follow the slope, okay? Which means, and here's how I'm going to do it. I'm going to still stick with my red color. And I'm going to plot that line as if it's a line, not a dashed line. I'm going to plot the y-intercept at 0, 0. And I'm going to follow the slope. Up 1, like 1 cell, like 1, tick mark for me, over 1. Okay, I know that that's not quite even, but up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. I don't need to plot all these points. I just like to. Okay, 2 points determine the line. Oh, that's a gross one. 2 points determine the line. So really, I only need 2 points. But I like to plot them all, and you're going to see why. Because these are going to be dashed anyway. Right? Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. I hope your scale is even, left and right as it is up and down. But either one's fine. Because now that I have these dotted, these dots, right, these points on this line, those are like the centers of my dashes. It's going to straight edge for sure, but I'm going to just kind of extend through them. The straight edge would kind of help guide me a little bit better if I had that guide. But now that I have every single one of those points, what I have really easily now is kind of the center of each of my dashes in my slant dash. And those are going to be my arrows, my guides that I'm going to try to shoot for when the time comes. All right, cool. All right, last one. Then we're out of here. All right, point time. X-intercept at 2, 0. X-intercept at -1, 0. Y-intercept at 0, 2. And then a bunch of points. Okay, be careful plotting these correctly. -2, -1, and a little butt. -3, -2.5. So right there. We should be getting closer and closer to that asymptote. -4, -3.6. -5, -4.07. Absolutely. I mean, you can just see I'm so close already. I'm going to be heading towards that arrow on the right-hand side. Okay. Same thing on the other side. Okay. -1, 0 already there. Okay. -1/2, -0.8333. This one's probably not super crucial of a point, but why not? It helps guide me. 0, 2 already there. 1/2, 4.5. This is a big one. 1, 2, 3, 4 and a half. That's a good kind of guide for me because now I'm trending up towards that side of the vertical asymptote. And I'm good to go. Cool. Nice. Vertical asymptote x equals 1. That one's there. Okay, 1.5, -2.25, -2.5, sorry. -2.5. 2, 0. And then the rest of my points. 3, 2. 4, 3.33. 5, 4.5 up there, sorry. And then 5, 5.6. You see, like, we're just getting closer and closer and closer to that asymptote. So as I trend to the right here, I'm definitely underneath that asymptote. Sorry, ignore that stray over there. So I'm going to put, oh my God, I can't even look at that. I'm going to put my arrow, let's make a thinner one, just so it stands out. I'm going to put my arrow over there on the right-hand side, right underneath that arrow. But as I move down this way, down I go towards that one down there. And so now I can connect them. And I mean, seriously, like, I hope you are pressing graph in your calculator and seeing the same kind of picture that you're drawing. Right, it's going to look like that. Hug the asymptote until you get to your first point. So I don't trip and fall. Hug the asymptote until you get over there. Again, ignore that straight mark. And we're done. Thank you for watching. If you're still here, you can go. You guys are awesome. But I hope that helps a lot. Okay, 2.7 homework due Sunday before midnight. You'll get review hopefully by then as well. And then Monday in class, we'll work on the review. Monday at home, you'll just work on the review. Tuesday, same thing, but vice versa. And then Wednesday, depending if you're in school or at home, you take the in-home, the at-home or the in-school one, and vice versa on Thursday. And then Friday, I will keep you off. We will just take the day off. Okay, hopefully. We'll see. Maybe I'll grade the test and we'll see how that goes. But that's my hope, my plan. I'll give you the day off. Okay. There you go. Thanks, everybody. Thank you for being here. Thank you for watching at home. And thank you for watching this recording. Have a great weekend.
Thank you.